Welcome to episode 12 of Under the Hood. So today, we are going to go really under the hood. We are going to talk about the AL runtime. And with me today, I have Mads. Hello, Mads.
Thank you.
So tell us a little bit about yourself. What are you working with?
Yeah, so I'm Mads. I work on the AL runtime in one of the server teams. I'm a principal software engineer, and I've been here for, 10, 12 years, something like that. I started as a student worker, and then I have actually remained in the same team for like 8 years in a row.
So you know a lot about the runtime, the AL runtime.
Yeah, I learned a lot about it, but it's also impressive, right? Because it's actually an old language, and even though the runtime has kind of changed, a lot of the things have stayed the same. I mean, I'm sure you can remember a lot from how it was back then, and
Were you there before when we had Seaside?
Yeah, so I actually made changes in Seaside.
Okay.
I made changes in code that was older than myself, and I found that immensely funny, right?
Yeah.
30-year-old code, and I was like, what is this? But when I started full-time, I think we got rid of Seaside just around that time.
Okay.
So almost all my time has been in the new runtime.
So the AL runtime, where is that going on?
Yeah, so the AL runtime is located inside of the NST, so kind of the server. And when I say the server, we actually kind of have two things we call servers. We have the web server, and we have the NST, or the traditional server. And kind of a lot of things runs in there, but the main thing is the AL runtime, and that is kind of when you have clicked on a page, you might click an action. It goes from the browser to the web server, and then it hits the NST, and we begin executing, and we'll run your code, or there's a little bit of orchestration before we execute the code. But yeah, it's overall there.
So the part you're working with is the part in the NST.
Yeah, that's the main thing I do. There's always a few other things, like when I add a new feature to the language, you often have to update it in the compiler. Like you just have to say, the compiler now knows about this. Let's make sure that it knows how to call into the NST. Or sometimes you add it in the AL code that it can actually call it or something like that. But most of the time, yes.
Yeah. Okay. What does NST stand for?
Navision Service Tier.
All right.
Yeah, that was a test.
That was a trick question. All right. So walk us through what happened when a line of AL code executes. So we had another episode with Espen when we talk about the compiler and how that works and how we generate the code and how it gets transpiled to C# and all these things. But at runtime, what happens? Let's assume you have a line of code in, say, in a code unit. So what's going on? Walk us through what's going on there.
Yeah, so if I can start a little bit before that, if I may. There's actually, if we think about it instead of a line, but like a block, and by block, in this case, I talk about like a method. So when you call a method, an AL method, let's say from another AL method, we have to set up a call stack, or what we call a stack frame generally. And we kind of have to set this up for a few reasons. We do this to kind of measure how long it took, so from start to end. So that's an object that we just allocate on the heap, and then we put in a bunch of information that we use to track. So that's kind of the first thing we do. And then there's kind of a little bit of this kind of overhead, and then we get to executing an actual line of code. And executing a line of code is actually pretty simple most of the time. It's really just whatever C# wants to do.
So it's all C# running at that stage, right?
Exactly, right? So we have, and that's the funny thing, we kind of have a runtime on a runtime, right? Because we are a runtime, but C# is also a runtime. So, and then from there, if you look at whatever you do, let's say we do set range on a record, right? Then what the runtime mostly does is it provides the standard library. So, or not standard library, actually, it provides the built-in functions for the language. So setRange is a method that we implement. So it's called AL setRange if you go into the NST. And we will provide the implementation of setting a range, right? Setting a filter. So that's kind of the main thing that will happen. There's a few things about like keeping track of which record you're doing it on, but most of that is very implicit.
So it's not quite an interpreted language, but it kind of had a little bit of this flavor, right? Because
there's no interpreter, but there, because C# is a JIT language, so the just-in-time compiler. So what our compiler emits is it takes AL, and then it makes ours actually makes C#, and then there's a compiler that takes the C# and makes common intermediate language.
Yes.
And then the common intermediate language, the C#'s JIT runtime will make into assembly code.
All right. So lately we have done a lot of investments in to improve performance, and more specifically performance of the AL code running. Exactly. So like the idea being, you wouldn't have to change, or partners and developers wouldn't have to change their code, or not, not always, but we'll get back to that. But they would get immediate benefit from some of the things we run. So tell us a little bit about these features and give a few examples maybe.
Yeah, I think there's maybe a little bit of a backstory also to be said. I think CAL or AL came from a time where there was maybe a little bit less focus on creating a language that was meant for being high performance. The language was maybe more originally meant for being very simple to make business logic and represent it as easily as possible, right? There was very much this focus on that. And then over time, we began taking the product into the cloud, and then we began seeing more directly kind of the impact of running the code. And from that, I think we kind of realized, okay, if we got to do that, and the on-prem, there was maybe this a little bit of a hack they can do, which was just buy faster hardware, right?
Yes,
just throw more RAM, get a faster CPU.
Maybe even tweak the SQL or...
Exactly, keep SQL as close as possible. And when we went into cloud, we had to take a little bit more care of this, which is actually good, I think, because we then had to do more about it. And I think we took the language and we kind of looked again at it and said, like, okay, it's really nice to have this language, which is super easy to write and go to the database. It's just like one line of code, right? It's amazingly smart. But on the other hand, it also doesn't really allow for super optimal code in that way, because there is that abstraction over it. And I think in software engineering, you talk about this concept of leaky abstractions. You have like an abstraction that's very nice and clean. But then if you want to use like the super performant things, you kind of begin saying like, well, the abstraction is this, but if we know what the underlying thing is, then we can do it a little bit faster. And I think in some ways we kind of did this, especially towards SQL with some of the things. So
can you give us a few examples?
Yeah, so we originally had in the language that, when you go on a record and you do a find, you can do it against, it's an abstract idea that you can do against SQL, or you could do against a temporary table, or you can do against CRM, or whatever it is, right? We have multiple. But we kind of recognize that, like, if you want to do data transfer, which is, for example, one of the things you did, you can only do that against SQL because it explicitly generates a SQL query. So we kind of began saying like, well, we know that they almost always do it against SQL. So let's kind of leak that a little bit. So I think data transfer is a great example of that.
So we introduced that a couple of years ago, I think.
Good question. I think it's it's like 1.5 years now. I think something.
So
like
that does require some code changes, right?
Exactly.
To adopt it.
Definitely.
Can we see a good adoption of this?
Yeah. So data transfer it was actually one of those where we had a very explicit place we wanted to use it. I remember Nicola had some good places where he wanted to use it. And we have actually slowly been opening up for it.
So in our base app, right?
Exactly, right? Yeah. We have slowly been opening up more and more places. I remember Nicola's case, because it was the first one, so I remember it very vividly. It had, I think it was during upgrade code, they were trying to move some fields out of base app into other. And he had this case where he was trying to do it, and if you didn't use data transfer, he found the fastest SQL instance he could get on Azure. And it took 3 days to do it, and it timed out. Wow. So it never finished, right?
And that was just to kind of give a little bit of...
so there he just did...
What happened is that it's like looping through a lot of records.
Exactly.
That was if you don't have the data transfer, there was no other way
Exactly.
Right? Which is very, very slow. And SQL has the ability to transfer a large amount of data natively,
Exactly.
but we didn't really quite surface that all the way to AL. So that's what DataTransfer basically enables, right?
Yeah, so when we then uptook DataTransfer in that exact scenario, I think he had one example with 17 million rows, which is a fairly large amount of data.
From a real customer?
A real customer, exactly. And we then used DataTransfer on it, and it dropped to 40 minutes doing the same operation, and that was just on a normal database.
So for several days to 40 minutes.
Exactly. I was very happy with that.
Yes, I was going to ask you. So, can you say roughly what's the factor of improvement you get with DataTransfer as opposed to a loop type of implementation?
Yeah, I mean, so it was. We were trying to establish that actually. We were trying to get like. And we kind of saw it as if you do it on smaller tables, it's not a lot. Like if you do it on 10 rows, it doesn't matter at all. But when it just scales linearly with DataTransfer roughly, and the other one it kind of goes like this, right?
Okay.
So you really want to use it when you have big tables. I think I once looked up in telemetry how many rows we transferred maximum in one data transfer, and that was 70 million rows.
Okay.
And that took a few hours. I don't even want to know how long that would take.
That's probably not even doable.
Yeah, probably not.
So what other, we had other features like set load field or ReadIsolation, which also were targeting performance improvement. So tell us a little bit about those.
Yeah, so set load fields we originally called partial records, but I think the community has just taken to the function name instead of the name of the feature, which is fair enough. That one, it kind of came together with a few other things. So set load fields requires manual uptake in your AL code. And we have seen quite a bit of success there. We have some of our MVPs who really champion it. I know Waldo is talking a lot about it. I love that.
Thank you, Waldo.
Yeah. And
so both DataTransfer and set load field, they do require some code change.
That do, but set load fields is automatically being applied if you do API calls on API pages. And that was actually where we saw the biggest gains because those ones are often very simple. They just read data, right? And if we could do that, if we could limit the amount of fields you load, that is exactly where it's great. Now, originally when we made it, and I think this is actually an interesting point, when we made it, it was back when we had our old extension model, like the data storage model, where every single table extension had its own table in SQL. As you probably remember, we switched from that onto where we have a base table, and then we have one extension table.
Exactly. The companion table,
And back when we had the old model, it was partial records or set load fields was even stronger because it could not just remove one join, it could remove n joins in SQL, right? Nowadays, I think removing one join is still great, and removing an amount of fields, right? If you just need to load out a single field or two fields maybe on something like, let's say, the item table that has, I think, 150 fields or something like that, it's great there, right? But when we did the other change, it kind of changed a little bit how important partial records or set load fields was. Now I would say set load fields is more to be used in performance critical code, like where you're looping through millions of rows. Think about it there.
Yeah, okay. What about ReadIsolation?
Yeah, so ReadIsolation is like one of our newer things, and it came together with another feature we wanted to do. It's called tri-state locking, right? And we actually wanted to do tri-state locking first, but then we swapped it around and did ReadIsolation first because we got a lot of feedback from internal AL developers that they also wanted that apart from tri-state locking.
So what is it?
Yeah, so it's essentially more fine-grained control about which locking semantics or isolation semantics do you want to read from SQL with. So back in the days, there was essentially two choices. There was you could either do read uncommitted, which is like we essentially don't care at all about like the state of data. You can get dirty reads, which means
meaning you can get like if somebody else is in the middle of a transaction, you might get some consistent data or before the transaction get committed.
Exactly, all bets are off, right? It's very fast because you don't get blocked by other people, but all bets are off. And then you had you could call lock table or do a write, modify for example, and then you would get update lock. And update lock is a pretty strict one. It essentially means like, if anyone has read with update lock or has done a modification, then you have to wait. So that's a pretty strict guarantee because, if someone calls lock table and you call lock table and you both read, you're not allowed to read. So this was kind of the core of the product.
So you get a consistent data for sure, but you pay the price on maybe some locking and performance eventually.
And especially in the read scenario, that was kind of the weird thing because a lot of people, they were like, oh, I don't want to read with read uncommitted because that's like all bets off. But they want to read only what has been committed. So they don't want the dirty data. They want they know what's committed, but they don't want to block someone else. So they kind of wanted this in between, which is generally read committed. So we wanted to give them that ability. And then we just also gave them the other things because why not do more?
And that's what ReadIsolation does.
Exactly, yeah. It says when you read, and it's only for reading, you can say, okay, do I want read uncommitted? Do I want read committed? Repeatable read or update lock?
But you also need to specify it in the code, which model.
Exactly. So it kind of gives you the ability to be more in control. And I think in general, this is what we have been doing. We have been affording some kind of flexibility or more power at the cost of doing a little bit more.
But still, I mean, hearing you talk about it, there's still a lot of complexity in it that it's abstracted for our developers, and they don't need to they need to specify what they want, but it's more like we take care of all the intricate things with a SQL and making sure all the things are working properly.
Exactly.
Right?
Yeah, and if we take that and say well, what's tri-state locking then, right? Because tri-state locking is kind of the companion piece for it. So as I said earlier, you either read with read uncommitted and then update lock. We kind of imposed a third one. I mean, you can see my naming is very, very creative, right? We added a third one in the middle, which is after a write, let's say you call modify, then you now read with read committed instead of update lock. And then you still get this where two different sessions can read each other, but they cannot, and they don't block each other. So that was kind of what we wanted to achieve with tri-state locking.
Have you seen the effects of this on telemetry, and or also heard from ours?
So some of our partners are very happy about it. I know Dulio, he presented down at I think it was last year in Vienna at Directions. He had a talk there. And I was standing listening in, and at the end he was like, "Oh, and by the way, thank you, Mads." That was very nice to hear. So there's some really cool things there. I've been trying to gather do we see less lock timeouts, and it's a bit hard to do because you have to. For a long time we had tri-state as an opt-in feature, and then now it's kind of everyone is using it. But you can still disable it if you call lock table, and we still have a lot of places that do that.
Yeah.
So it's a bit hard to see, but in cases where we know it has been uptaken, we have seen quite a good, and especially ReadIsolation, we have a lot of internal AL developers who has begun using that and really found it nice.
So you recommend people who haven't adopted it and look to
definitely
try get that into their
exactly. If you see locking issues, it's definitely one of those tools that you now have in your toolbox.
Yeah. And again, maybe quick reminder, how do we detect locking issues?
So I think often you kind of get it from your customers complaining that they get this error that another user has modified the data. But telemetry is of course the partner telemetry, right?
So do we have also work and features which get performance improvements or provide performance improvement without requiring code changes?
Yeah, I think in the last couple of years the best one of that is moving from the many table extensions to one, because there was just nothing our customers had to do at all.
So it was just entirely under the hood.
Exactly, you just upgrade to the next major. I can't remember when it was, but it was a couple of years ago, and then it's just magically faster, right? So that was a great example. And it's one of those things we think a little bit about in the platform when we think about what features do we want to do. Because it would be lovely if all of our features could just, be immediate. So we have to make that balance of we know uptake is not that easy. We have a lot of AL code and it's old and some people don't, maybe they can't just change it and stuff like that. I know some of our users or our customers out there have something that was developed at some point and maybe the developer is no longer there or something. So it's of course nicest if we can make something that's just immediate.
Clearly that's the best because nobody needs to do anything and everybody, gets a little bit happier. Right?
Exactly.
So when we prepare for this, you had some things you wanted to talk about. We prepared some questions a little bit and you say, okay, there's some myths we need to bust. So tell us about it. What do you want to, I guess there's some, you get some feedback on some things and...
so often it comes because people read the documentation or they read the function name and then they go oh, then it must be doing this. And sometimes the function name was named 20 years ago or something.
So some assumption on how the runtime is behaving. Yeah.
So a good example of that is lock table.
Yeah.
Lock table, I think it makes sense that it would lock the table, but in essence, that's not what it really does. So lock table, first and foremost, it doesn't actually do anything in the moment. It doesn't go to SQL and takes a big lock on the entire table. What it actually does is it says for all the future reads you're going to do, you will do them with the update lock hint. It also does do something to the data cache, but that's very specific. I don't know if we'll go into that here. But essentially it just means you can no longer use results that was read with a lower isolation guarantee level. But the major thing is that all future reads will be with update lock.
Okay.
And I don't think that's what the name kind of suggests.
All right. So any other myths you want to, while you have your audience here, any other myths you want to
so set current key is also a fun one, right? Yeah. Because you're thinking okay, a key, we have the concept of saying, oh, there's a key I can specify, I can say which fields, and you probably know it creates an index and stuff like that.
Yeah.
So you would probably think oh, then SQL uses it or something like that. And SQL does support that you could say use this index, but that's not what we do.
Okay.
What we actually do is we say you need to order the data, the resulting data, in the order of whatever field you have specified.
It's maybe a little bit misguiding.
I think it is.
Yeah.
We have talked about could we rename it, and the problem is it's kind of hard
break
to
a lot of people. Yeah.
Exactly, right?
Yeah.
So there's also this interesting thing when it gets to SQL that there's actually a pretty big implication for SQL on it, how it queries data, if you tell it to order the data in a different way. Because most of the time SQL will kind of optimize for, I want to read the data that I can filter away, so I only read as little as possible. But if you then ask it to order it in a different order, it kind of has to say, okay, I can maybe use that index to read with, but then I have to sort the data afterwards because they wanted this ordering. So sometimes SQL will then instead go in and choose another index that has the right order and then read all the data and filter it later. So it kind of has some interesting performance implications also. And I think people don't think too much of that. It's also hard when the name doesn't suggest it. So we have been trying our best to change the documentation of it to add there. I also have a blog where I document some of these kind of, I think maybe I demystify them, I would say.
We'll put a link in the comments so you can take a look at the nice blog.
Do we have any other really strange things that we have?
What about the temporary tables?
Yeah, temporary tables. I actually haven't documented that on my blog, so it's kind of anyone. I remember I saw on Twitter at some point, or X I guess nowadays, where someone was guessing how is that actually implemented. They were thinking maybe it's an in-memory table, but on SQL, because you can do temporary tables there, or maybe it's something else, and it is an in-memory table, but on the NST.
So we use NST, basically the memory of the NST process for that.
Yeah, we just have an in-memory implementation. It uses the very specific data structure called the AVL tree, which is a classic data structure. which is kind of optimized for searching, like a red black tree or some of these other ones, right? And then everything happens in memory, and it is actually quite transparent. Like the abstraction doesn't leak that much. It's quite fast because everything is in memory. And it behaves mostly reasonable, I would say. But it does have the implication that, the more you put in there, the more memory you use, right? So it's kind of a challenge there in some way.
All right. Okay, let's talk a little bit about the future. What do we have in store in the runtime? What should our developers look forward to? I mean, we don't say anything when it's going to be shipped. But we can talk a little bit of what we have on the drawing board, right?
Yeah, we have some big ideas, I would say, right? Yeah. I none of these are actually in code. I think when you present down at Tech Days, you normally have this like from the labs or something like that. And I think that one is maybe even closer to being real. This is idea level. Like this is one step before. We don't even have it, and I would say there's 3 things we're thinking a lot about right now. And one of them is dynamic queries.
Yes.
I've talked with so many of our MVPs about this, and they've wanted it for a very long time. And we all agree it's a good idea.
Yes.
So one of the problems with queries as they are right now is that you kind of have to write them as an AL object, and they're not really extendable. You can't.
So it's a design time decision.
Exactly.
You can't change them at one time.
And then they also sometimes have feature creep. So they might have been designed for like a very specific thing, but then someone comes and goes like, it would be nice if I could use that. Let me just add a little bit more to it, right? So, and that's fine, but the idea is for them to be as small as possible and just do what you need. So we have kind of been thinking about like, what if instead of making them at design time, you could make them at like kind of runtime. So you could say like
some of them.
Yeah, we would keep the old ones, of course, right? But this new idea would be able to say, I want to read from this base table, join in this other table, and then maybe join in a third table, but I only want to do that if this record has a value or, some condition is set, right? So you can really dynamically create them. And the name comes from there. It's a challenge in the sense that we want to find a good model on how to write them because it is already cumbersome to write a query. What if you kind of use a query builder pattern where you say, I want a designer query, then I want to add this data item, this data item, this data item, these fields, these fields, these fields. This becomes quite a lot of code. So we want to find a succinct way to describe that. So we're thinking a lot about like composition. So you kind of maybe have some code that default kind of adds what you need a lot of the time. And then maybe it actually becomes pretty easy to do. Or another way is to go from a record that is already instantiated and say, based on that, design part of the query. We have also recently had some talking, like very recently, just a few days ago, about the MCP server you could use AI that knows about all the tables, because we expose that to AI. So in the MCP server, it could probably use this idea of knowing how all the tables look to generate just what it needs to look up. And
but we would need to have the ability to generate queries on the fly to start with, right?
Yeah.
But then, the addition of MCP servers and AI would be a great combination because you could express things, maybe even in natural language, and then create queries on the fly or even programmatically.
We're thinking about like maybe the MCP is a good way to start testing it out to see how it works. Because if that one is missing something, we often find that like you can add more metadata or like better documentation that will also help the average user, right? The average developer out there. So we might experiment with it there first and then get some learnings and then take it to AO.
All right.
So that's the first thing we've been thinking a lot about. There's a conceptual idea, which I like to call bulk events.
Yeah.
And that comes from, we have delete all and modify all, which is a great, like one of those, again, it's a league abstraction actually. It's one of those places where we can ask SQL, instead of like line by line or row by row, to do like delete, you do a find set and then delete one row at a time, we can kind of say delete all that matches these filters. But we have the problem that since AL is row by row based, you can go in and set a on after modify trigger or on before modify, on before delete.
And that will often generate a lot of events.
Yeah, and if you have that, then we actually say, well, then we can't use the bulk statement. We can't just do one big delete. Then we fall back to doing the row by row deletion. And that's very slow.
Like that's for performance, yeah.
Exactly, performance. Yeah. And if we could do what we call a bulk event, so we could say, okay, you want to kind of subscribe and do something. Well, what if we gave you the ability to subscribe on not row by row, but like on the bulk delete or bulk modify?
So you, instead of getting an event for each row that gets modified, you get to know, okay, we've modified this
the filters that match
in
that,
one
right?
event instead.
And then we wouldn't have to fall back to the row by row approach. Like I actually just recently talked with one of our internal developers who had a performance case from a customer, and the problem was exactly that it fell back to this row by row approach, and then it got super slow. So that's one of those things we would love to do. And with that, we also would love to, if we could, move a little bit away from row by row to doing set-based things, which is what SQL is meant for. Like, it's a set-based language, and that's where it's really fast. So if we could take more and more and move it towards set. Like if you're used to C#, you might have this idea of link, which is like you do where this, then do that, right?
Yes.
If we could in some way have that nail, that would be a very strong concept. Now, it would probably be quite a big change to AL, but that's one of those big ideas we'd like to get towards.
So some things to look forward to.
Yeah. And this is not next release or the one after. This is like...
No, but I mean, it's this runtime, it is constant evolution, and we keep adding to it and improving it, right?
Yeah.
So if you had one thing you wanted to redesign about the current runtime, so one thing you would say, hey, when you come to work every day, you look at this runtime and say, there's this thing, I wish I could rewrite it, right? What would that be?
Yeah, it's there's maybe a few things, but I do think fundamentally if we could go back and say the row by row, like what we just talked about, that would probably be the biggest performance change, especially when you do big data-driven things, right? If you just open a page and show 50 rows, it doesn't matter. It's fine. Yeah. But when we do, for example, upgrade code units that often touch a lot of stuff, they're doing things row by row is really hurting us. So that's probably one of those things. That's the biggest kind of would really change that type of operations. But kind of in the day-to-day things, it probably wouldn't change so much performance like opening a page, for example. I think in the open a page scenario, it's probably maybe more the fact that we do so many triggers. So I think often we do you can do the on after get current record, which just does one trigger execution when you open a page. But you can also, here we're talking a list page, you can do on after get record, I think it's called, and the on next trigger. Because they execute every single time, if you have those ones and you begin putting logic in there, it can become very expensive. We have seen quite often when they have slow page openings, it can be because they have added a lot of logic in there. So that's, I guess, also a little bit of a row by row thing, actually. So, I mean, that's the big dream. If you could change that, that would have been cool.
All right. Before we conclude, do you have any word of advice for partners and developers? What should they do if they want to leverage all the great stuff you just talked about in a runtime?
I think maybe the first thing is they should do is figure out what their hot path code is. And by that I mean figure out, like, is this something that gets executed 10 times a day? Or 10,000 times a day, or maybe millions of times a day. Because if you find those ones, we have now added things in the toolbox, what I've been talking about earlier, right? And if you know that these paths here are your really hot path code, And they change from scenario to scenario, of course. But if you analyze these ones and you get down to, okay, this is where we have to be a little bit careful, then you can begin putting in your effort. I think you should start with something like the profiler, sampling profiler. That one can be a good tool. I think sometimes developers have this idea of what is slow, and then when they actually run a profiler, they figure out, oh, wait a second, it was actually somewhere else. I mean, I have done that many times, right? So I think if you start there, you get down to like just these like maybe functions here or something like that. Then you should begin applying the things that have come in the toolbox. And this is not just the things we've talked about today. There's also stuff like the dictionary data type, which in some cases can replace the temporary tables. Temporary tables is great also. But if you need the quickest, just check if there's a there or just look up that value.
So dictionaries are better.
Dictionaries is way better. Asymptotically, it's log n versus constant time, if we are to be nerdy. So I would definitely start by narrow it down, and then look in the toolbox, find the great tools that we have added over time, and try to apply them. I think, for example, set load fields, we have had great experience, especially if you are only in read scenarios and you're reading millions of lines of rows. That can really help you out there, for example.
All right. Well, thank you, Mads. That was really under the hood. So let us know in the comment if you want to hear. We could talk about that for hours, right? There's a lot more things into what's going on in the NHD and the runtime. So let us know in the comment if you want what you would like to hear about, and we'll make a new episode about it. Thank you, Mads, and thank you for watching.
Thank you.